In this video we're going to take a look at some of the forensics challenges in the HackTheBox Cyber Apocalypse 2021 CTF. The first challenge we'll take a look at is Key Mission. So the description says, the Secretary of Earth Defense has been kidnapped. We have sent our elite team on the enemy's base to find his location. Our team only managed to intercept this traffic. Your mission is to retrieve the Secretary's hidden location. And we have the file downloaded, so if we go and take a look at this, it's a PCAP file, so we can open it up in Wireshark. And the first thing we might want to do is go and have a look at the file properties, get an idea how long the PCAP is. It was running for 1 minute and 45 seconds, how many packets are in there, the sizes and stuff like that. We can then go and have a look at the protocol hierarchy and see what kind of data we're looking at. So we have this text item here, which is 8% of the packets. We can see that all the packets are USB data. So we could select that and go and try and have a look through some of these to see if there's anything of interest. We can't select these, or follow like we might be able to with some other protocols. But you'll see here that I'm just gonna exit that and just have a bit of a scroll through, and you'll see that I have this column HID data, which is a column that I manually added here, the USB HID.data, and I added that for some other CTF challenges in the past where this is basically the key presses which are coming through. So knowing that these are there, I essentially approach this in a similar way to the previous challenges that I've done like this. You can have a look at some of the HackTheBox retired challenge walkthroughs that I've done in that playlist. You'll see that we use similar techniques. So what I'll do here is use T-Shark to extract those fields. Let me take a copy of the command that I used previously. In fact, so we can run T-Shark, we pass in the PCAP, and then we just say that we want to extract that USB HID data, and it'll print all of that out. So we print all that out, and then we say, alright, well, we want to print that to HID data, print it to a file, and then we can go and I just basically went and grabbed a script here, which there are a few different scripts which I've used in the past for these challenges. Let me just make sure I'm referencing the correct person or people. You can see here, this is the blog that I took this from. We have a script in here which basically maps the various codes to different keys, and I essentially took this script. So let's go and open that up. Codium USB extract, and yeah, this is just I didn't modify this at all. So this is just their script, line for line, and we can see that it takes in a file name, and it's going to print out hopefully our flags. So let's run Python USB extract and then pass in the HID data, and you'll see we get this string back. So you can see that we've already got what looks like part of a flag in there. What we need to do now, let me open this up in Sublime and paste that in. So we might want to replace some stuff. We can I always forget is it Control and H for replace? Yeah, okay. So we can say we want to replace, for example, space with an actual space. Let's replace all, and that'll clear this up a little bit so we can see we've got a message, and then we have our flag here towards the end. So let's try and clean up this flag a little bit. And we can see we have the delete key here. So what's happened is they've typed in this place equals 3, and then they've hit delete twice. So let's remove the deletes, and then let's hit delete twice. And then they've typed in -3, and then they've hit delete twice again, so we'll delete that and that. And then they've entered _3, and then they've done a delete 3 times, so we need to 1, 2, 3, and basically go through this. Actually, it was a little bit, let me see what the actual flag was here compared to what we have. I'm just going to copy and paste this from what I submitted. Okay, that was the actual flag. I was a little bit confused because I was trying to submit some different flags, and I thought it would, we would need to kind of remove some of the characters like that. But essentially, that was that challenge anyway. The next challenge is called Invitation, and it says, last night I received an invitation, but after I accepted, some weird things happened in my computer. So we have a downloadable part to the challenge. It took me a little while to solve this one, probably longer than it should have. Let me run through some of the things that I tried, and then how I eventually solved it. So the file we downloaded was invite.doc, so we can check the file type and see this is a 2007 plus Microsoft Word document. We could do our usual stuff and have a look for strings in there. You can use something like binwalk or foremost to extract this, because essentially this is like a zip. So in fact, let's do binwalk -e invite, and you can see that it started to extract some things there. Let's run tree against the output, and you'll see that it's extracted each of those individual files, so we could go and look at those individually. We can also just open up the file. Let's open it up in LibreOffice, and you can see here it's asking us to enable macros, so it's a good hint that we need to go and have a look at the macros. We can do that in the tools section, and we can run macros, we can edit them. So if we go into edit and then select the document, and you can see that we have this obfuscated function name. If we open that up, we've got some obfuscated code where this function is being repeatedly called with some hex values, and they're being concatenated together. We have towards the bottom here, we have a shell command which is being executed, and again some hex values in there. So we need to go through and decode some of those and try and work out what's going on. I did go through and kind of manually try to decode some of the stuff and work out what was going on here. This is like a function to convert between hex, but there are tools that are available to us to try and do some of the deobfuscation. So let's go and take a look at that. So if we type OLE here and then hit tab, we have some different tools that are already available. OLE VBA is what I used here, so if you do OLE VBA -help, and we'll see that we have some different options here. In fact, let's just try and run it without any parameters, and you can see that it's actually decoded some of the hex values. So you can see here this is decoded to PowerShell, and we have the enc for encoded flag hidden, so we know it's going to run a PowerShell command towards the end. It's decoded some of these hex strings into base 64, or it looks like base 64 strings, so they would need to be decoded further. But if we scroll up towards the top, let's see. So we can see here that it's found the autoexec. So it's found some suspicious or dangerous functions. We have the shell command, we have char, and you can see here that this may be an attempt to obfuscate specific strings. We can use the deobf, and we can also use decode as well to decode hex strings. So we can try and run it again and provide those decode, deobf, and we have some other options as well. So this doesn't put this out into a great format, so if you want to, let me check the help again. So you can output this into JSON, you can use a detailed mode. I think the closest I got to getting this working, or to getting it decoded properly, was using the reveal. If you use the reveal flag, and you'll see that because we're using Python 3, we have these Bs, so it's tried to concatenate the various base 64, it's decoded the hex into base 64 encoded strings, and then it's concatenated them together, because that's exactly what's happening with the macro, right? So all these ands are concatenating those together. But whenever it's done that, it's not removed the Bs to notate that they're bytes. So you can use Python 2 to do this. I'll just activate my Python 2 environment, and then if we run that again, now it won't have those B's in between it. So let's take a copy of this. It's attempted to decode it here. You can see there, deobfuscated, experimental. So if we open up, let me open up Codium new.vb and paste that in there, and let's have a look, turn word wrap on. So you can see that we have these strings, and it's a bit easier to work out what's going on now. So we have this shell command which is being called. It's calling PowerShell, and it's passing in these parameters, where we can see that the first parameter is this one right here, the second parameter is the second one, and then etc. So we can basically go through, and if I take this to, we can go to ASCII to hex.com or CyberChef or something like that, and if we just paste that in the base 64 and decode it, you can see it's decoding there, decoded with some extra characters on it. Let's open up Sublime, paste that in, and we can just remove those. So we'll replace all of those with nothing, and we can see that then we have some quite obfuscated PowerShell code here. And actually, if you take a closer look at this, we can see some things in. For example, we have C HTB, and then so there's the beginning of our flag in reverse order. And if we reverse this as well, let's reverse that, MALDOCS_AR. We can see there we're getting maldocs R something, so it looks like we've got a partial flag. We also have the beginning bit, the CHTB, so that's great. So we can basically go through that and do that with each of those sections. And where is the code? So we can do that with each of those sections. The problem that I was having is that I was able to decode this. This is base64 decoded, base64 encoded. I was able to decode this, and able to decode this, able to decode this. The bits that I weren't able to decode were where we have this function being called. So this string right here, if we take this and try to base64 decode that, we don't get anything useful. And I couldn't work that out as to why that wasn't working. So let me show you what I ended up with here. So I'm just going to paste over this for a second, just so we can still keep the syntax highlighting up. So basically, I decoded everything apart from these two parts, which I wasn't able to decode, which seem to be our most important parts anyway. So we have this bit at the beginning, which is what we had already found there. But it was hard basically putting this together. We didn't have quite everything. This is the payload. So this didn't seem to be related to the actual getting the flag. A lot of this stuff in here isn't related to getting the flag. So let me just go back and show how I eventually did solve it. I would actually like to, I'd be interested to see some other solutions in this as to how to solve this more manually, because if I hadn't have been able to get the initial decoding done with an automated tool, I would have struggled to get those last parts decoded. So let me just show anyway what I did do. I use this Viper tool. If we run, we can run Python Viper monkey, vmonkey, and then pass in the invite.doc. You see it starts running through there, and it's passing the VBA code. You can see there it's got the initial code, and as it's going through, it'll show it as it's decoding and parsing. So it's taking a little while. Okay, so we can see there sub auto open 9 functions. It's decoding these hex values, and you'll see it loop through and through and through, and it'll keep outputting eventually some base64 strings. Basically, I left this running for a little while, and eventually it came back with a final string, which is this PowerShell exe, no exit, the command, and then our base64 encoded strings. So if I take this now, and it says it's labeled it there as a shell function, let's take that to our Codium, and we can see then we have our PowerShell, we have this base64 encoded string which is going to be decoded whenever we run it. So let's go and supply this here, convert, and if we take a copy of that back over to Sublime, and again we'll replace these with nothing, and then we get our full original code. Let me copy this over to Codium, swapping about back and forth here a bit, but now we've got everything we need. So our code of interest is this line right here at the beginning, and then this line here as well. So rather than trying to decode this manually, which would have been a bit of a task, I took this over to the Windows VM to run this in PowerShell. So we're basically going to paste both of these strings in as are. So let's go over to Commando VM and open up PowerShell, grab a copy of the first command, paste that in. You can see that it's run the command, but obviously we don't have any output, so that's not much use. Let's try and run our second command anyway. Run the second command, still no output. So what we can do here is run get variable, and it'll come back and we'll see that it's assigned these variables here, CHTB, maldocs R, and then we can see the second part of the flag now, the new meta. So that's how I solved that challenge. It took me a lot longer than I would have liked, but I'm glad I got it solved. I'll be interested to see some other solutions to see how to deobfuscate these scripts a little better. I'm not too not too good with macros and Visual Basic myself. The next challenge is called Alien Phish, and the description says, "This PowerPoint presentation was sent to the top leadership of the human resistance effort. We believe it was an attempt by the aliens to phish into our network, find the malicious payload and the flag." So we have the file to download. Let's go and take a look at it. I didn't solve this challenge myself, it was a teammate. I'll go through some of the things that I was thinking about the challenge, some of the things that I tried, and then we'll look at the solution at the end and where I was getting stuck. So we have a PowerPoint file, PowerPoint 2007 Plus. So I assumed that, like the previous challenge, this would be related to macros, but let's just check the strings first of all. Anyway, we can run strings -n10, and we don't really see too much here, but we can get an idea of the structure of the file anyway. We can also, if we want to extract these, we can just run binwalk -e, and you can see that we've got those all separated now, so we can go and look into them separately. So we'll open up the file and see that, like in the previous example, we have a message here telling us to basically disregard the security pop-up. It says that it uses advanced PowerPoint features, press F5 to enable these, and we have one slide available here. So I'll hit F5 anyway, and we'll move our way through, but we don't get any. So we get here, this PowerPoint is not supported, please try again later. If we go and have a look at the macros, we can go into edit macros, and there actually isn't any. So this is where I was getting confused, and eventually my teammate ran this. I tried to run this on Windows as well, but it was also it wasn't in Microsoft PowerPoint. I don't have Microsoft Office, so I wasn't getting this alert. But my teammate noted that whenever they ran it inside Windows, the PowerPoint has a actions section up here somewhere, and basically the action was set to execute some code rather than a macro, which also meant obviously that trying things like OLE VBA against it also didn't work. It didn't detect any macros or anything because there was no code there. So I was yeah, if it hadn't been for that, I would have probably found this a little bit sooner. Although, that being said, we don't actually need to open it up at all. So we'll look at how we can solve it without opening it. The other potential solution that I was thinking was, let me open this up in Codium, the extracted stuff, and you can see that we have the various slide layouts here, but we only have one slide. So if we go into the PowerPoint, you can see here we have slide 1 master, we've got slide here, slide 1. But if we go and have a look at our slide layouts here, this is all unsaved, let me see here, yeah. So if we go and look at our slide layouts here, we'll see that there's 11 slide layouts. So I was kind of looking through these and trying to work out, did we need to try and recreate some of the slides somehow, because it looks like some kind of drawing or something was being done on the page. You can see different coordinates and things here. So that's kind of what I was looking into, but it turns out we don't need that. So eventually, based on the solution that my teammate found, I identified that we can run grep and look for, well, there are a couple of things we could look for here. Command exe would have been a good thing to look for, but obviously hindsight is 2020. So we can see here that we have this XML slide 1 xml.rels. So let's go and take a look at that in Codium as well. And that's right here. So no, it's not that one, is it? Oh yes, yeah, it is. Okay, so it's this long string that we have here. Let me word wrap Alt and Z. So we can see it's running a command here. Let's take this. You can see there's some URL encoding at the moment. So I'll take this to CyberChef, and we can URL decode it. Makes it a little bit clearer. We still have some of these ampersands we might want to get rid of, so I'll take that out here and here as well. and that looks better. So if we take this now, what I did here was take this over to the Windows system, and we'll just open up our command prompt. I'm missing a C. Paste that in, and you can see it running through, and then at the end it basically produces this, or it's trying to produce this exe file with an unusual looking file name. So if we take that file name, and then let's go back to CyberChef on this system, paste that in, and base64 decode, and you'll see there we have most of our, oh there we go, okay, removed non-alpha characters. There we go, there's our flag, phishing without macros. The next challenge is called Oldest Trick in the Book, and the description says, a data breach has been identified, the invaders have used the oldest trick in the book, make sure you identify what got stolen from us. So we have a file to download, in this case it's a PCAP file, so let's just go and open it up in Wireshark. And we can start to have a look through some of the traffic. Something I normally do is go and have a look first of all at the protocol hierarchy and the file properties, capture the file properties, so we can see here what type of data is being sent, what protocol is being used, and there might be certain things that we want to try and drill in on. So we see that there's not many data packets here in these frames, so you might want to select those and then go through and see what's actually in those. And we can see actually, just in looking through, we can see .json, so there's some file names in there, but there seems to be some things repeating. But notice that the protocol is ICMP, and these are ping requests and replies, and the data is the same for the request and the reply. So let's go back anyway. Let's check the file properties. So it's the PCAP lasted 2 minutes and 40 seconds. That's how long it was capturing traffic. We can see how much data it captured here, and we might want to see if we can export any files. Let's go and check export objects. We don't really know what other kind of traffic there is there to check. I don't think there's no HTTP traffic. Alright, well let's just have a look then closer at the ICMP traffic. And we're going to want to extract some of this. Let me see, we can't follow this here to join the data together from these. So let's try and extract it with T-Shark. So the command that I use to do this, so I use this command, and we're just saying that, let's run that again, we're just saying that we want to extract all data that's ICMP, and where the data.data is selected, so where we have some data in here, it's going to extract it, and it's going to extract the data.data fields. But notice that we have our duplicates in here as well, because we're getting both the requests and the responses. So we could go through and just delete duplicate lines or something in our text editor, but we can also go and specify this a little bit closer as well. So the info there, we have the ping, you can see here the type, so this type is at 0 and this type is at 8, depending on whether it's a request or a reply. So it doesn't really matter which one we select, they're all the same, we just need to select one of them. So we can go back and specify that we want the ICMP.type to equal 8, let's say, and that'll stop us from getting duplicates. So let's do that again, and then we'll just print that to a file. And I'm going to open this up in Sublime. I'm going to take a copy of this, and let's go and open up CyberChef and see what happens when we convert this from hex. So paste this in here, and straight away we'll see that the first thing that I noticed here is we have the PK, which is a zip file signature. We can also see our addons.json, and if we go through here and scroll through, we will see quite a few file names and extensions. But obviously what's a clear issue here is that we have the file signature repeating 3 times here for the zip file. So it took me a little while to work out exactly what we needed to do here, because there didn't really seem to be any guidance on what to extract unless I'm missing something. So what I did here was basically let's grab the first line, just paste that in there. We know that it's going to begin with the file signature, which is going to be PK. So let's take away this bit, and that's the first 16 characters that we've removed. And then I basically just look to see when does the PK start again. So we can see that that's the 50 in hex. So if we look over, we'll see that it begins again here. So let's remove that, and what we're left with is 32 bytes. So let me see how to do this in Sublime. I did this in Notepad++ on my host machine, but we should be able to do \w16. We don't want the first 16, and then \w32, which we do want. And because we do want those, we should be able to just put those in brackets. That's what we're going to extract, and then that's going to be followed by 48 junk as well that we don't want. Oh wow, my VM's struggling to perform some regex. So yeah, we can just make sure that all lines up. It looks like it does, and then we're going to replace. So we're going to replace each one of these lines with what we've put in brackets here, which is the 32 hex characters. So we'll go to replace all, and that's extracted those nicely. So go back to CyberChef, paste those in, and you'll see straight away it starts to look better because we can see that we have this Finny, which looks like a directory, /addons.json, and then we have our JSON, and there doesn't appear to be any problems with that. There's no typos, everything's looking like it's in good order. So from here we'll just go ahead and save the file. I just save this to let's just call it data.zip, because we know it begins with a PK, the file signature for a zip. So we'll save it and take a copy of that, or move that from downloads to here. Double check the file type and make sure it is a zip archive, which it is. So try and unzip it, and you'll see here that we start to get some files. We can see our cookies, SQLite, and some stuff which looks like it's part of a Firefox folder. So let's go in here, and we might want to open up the SQLite browser, cookies, and we can go and have a look and start having a look through some of the data. But if we want to, I'm just wondering where the user profile is actually. Let's go back. We have our login database there. Where was the login? Logins.json, and then a key database as well. Let's have a look at the logins.json. Okay, yes, yeah, so we have our logins, and this has our encrypted username and encrypted password, and we can see there for the URL that was for. So we want to try and decrypt these credentials, and I've come across this in quite a few CTFs before, so I already have a tool for this. If we go to, I think we need to run Python, and tools, forensics, Firefox decrypt. Run Firefox decrypt, and then it'll come back and decrypt our username and our password, and that's the flag.